Howdy, folks. Let's go ahead and take a look at 59 and a little bit of 60. 56 through a little bit of 60. 56 is asking, what is the minimum function of 13x squared plus 29x plus 17? There's a couple of ways to do this, and the fastest way is going to be whichever way you're most comfortable with. But the main idea is that the minimum of a function is going to occur at some y value where the slope is 0. The problem and challenge with some of these functions is that the peaks and the valleys themselves are always going to have slopes of 0, so depending on the function, you can get multiple false values. In this case, we have a quadratic, and so it'll be all right if we do the derivative, set it equal to 0, and then plug it back in. But you see, that's a lot of steps. And so if you happen to have a graphing calculator, you just type in the function, and then analyze the graph, or go to the function analysis, and then pull the minimum, and then from there you'll get your value. Number 57. An open box is made from a rectangular piece of material by cutting equal squares from each corner and turning up the sides. Find the height of the box of maximum volume given that the material has dimensions of 50 inches by 40 inches. Okay, so I actually happen to have stuff already drawn out, or had solved it, but I thought I'd erased it. That way we can get a nice clean solution explained as it develops. Okay, so let's go ahead and take a look at 57. They tell us that we have a box to be made from material, and that is not quite to perspective or in proportion. Let's see here, actually. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right. And so we are going to cut out the corners of these of this material by some amount, x. And they want us to find out how much of a height is the box going to have. And that x distance is going to be how much of a corner we're going to cut it into. Because the idea is that when we flip this side up, like, it's going to be a height of x on each direction. Okay? So when we do that, we're going to lose some distance. Originally, let's say this was 50 inches. When we trim off the corner, we're going to have a length of 50 minus 2x in this direction. And in this direction, we originally were 40 inches in length. But the same thing's going to happen, and so this side is going to be written as 40 minus 2x in length. Okay. Now they want us to find out what height is going to give us the maximum amount of volume. And so we may want to write the volume of this box here using these expressions for the length and the width. 50 minus 2x times 40 minus 2x. That would be the base area, if you will, of the box. And then the height, x, would give us its volume when we multiply it. Okay. Now, in the previous question, we were talking about how the maximum and minimums of functions are going to correspond to locations where the slope of that function is 0. Now, looking at how many x's we are multiplying here, this is going to be some kind of cubic function. And that's not actually what a cubic function looks like, but the idea is that, there's usually something like that. It's an odd function with some kind of inflection. And so the idea here is that we're going to get a couple of values where we can get the maximum and minimum. So what do we want to do? Well, in our calculator, we can go ahead and have it take the derivative of this function with respect to x. Or again, you could graph it and then do the analyze function and have it find the maximum in this case, because we are trying to maximize the volume. We want the most amount of space occupied by this box. And so the idea is that when that happens, the slope, which is mathematically described by the derivative here, the derivative, as a math teacher used to say, in that voice, the derivative of that is going to be 0. So when you do that and you plug it into your calculator, you're going to get two values for this, because when you take the derivative of a cubic, you're going to get a polynomial expression, and that polynomial expression is going to have two solutions because it's quadratic. And so when we take the derivative of that, it becomes something like 2,000 minus, let's see here, 360x plus 12x squared. And we're going to solve for that being equal to 0. When we do that, our calculator says that the maximum volume occurs at 7.36 inches. Could be the minimum. In a more challenge, if I were to do this question, I would probably graph it and just go to the maximum instead of taking the time to test it by putting in the values, just because time is of the essence, right? Okay, well, that takes care of 57. Let's go ahead and take a look at number 58. What is A32 divided by the determinant of A if A is defined by this function? Or not this function, this matrix. Okay, so the challenge to this is, oh my God, I always forget these. And then I got them wrong enough times that I've eventually got to memorize them. No, I'm just kidding. I've got them mixed up this past Saturday too. Anyways, so what is the 3-2? Well, it's going to be the row and then the column. That I know for sure. But for some reason, if I'm looking at the paper rotated by 90 degrees, I'm going to go ahead and get confused, and I'm going to confuse myself by trying to unconfuse myself. And you know, that thing I do where I like think a million things and then stumble across myself. Anyways, so what is element A32? That's going to be 40 right here. It's the third row, second column. The one way I actually learned doing this was by programming this in some numerical methods class where we had to come up with our own like calculators and functions and stuff. And then it kind of got ingrained. But if you don't practice it, you lose it. Anyways, so it's going to be 40. Ooh, that's a little thin. Nothing wrong with that, but the view may be a little obscured because of the contrast there between orange and white. Let's bring it back to, ooh, there we go. 40. And when you do the determinant of this matrix A in their calculator, it gives you a value of 3090. So 40 over 3090 gives us something like, let's see here. Point 00129. Now, the important thing here is that if there are leading zeros in the value, those are not significant. So those two zeros, if we were to mistakenly assume they were significant, you know, and we wrote our answer in this way, that would be wrong. And so just be mindful of that. Happens to the best of us. I know I've done it. All right, let's go ahead and take a look at 59. So they want us to revolve this shaded region right here around an axis of y equals -1. So if we were to look at that, that's an axis all the way down here. So we're going to take this shape and we're going to spin it around. And the idea is that as we march along x, we can get a little ring here. And the ring in this case would have a little bit of an area like that from the top and the bottom. And the ring would have some thickness of like delta x or dx. And so the idea here is that we want to do an integral. We're going to be adding up a bunch of these little discs along x from wherever they intersect to wherever this bottom function intersects the y-axis. Now I'm going to go ahead and clear up some of this here because I feel like I have cluttered our image. Okay, so how does this one work? Well, it's going to be the area of rings or circles. And it's going to be this top circle. And so the area of that would be pi times the outer radius here, natural log of x. And that would be the radius. But that would be, the value of that would only be measured from y equals 0. We still have to add the fact that our axis is actually 1 unit lower down here at y equals -1. So let me go back and fix that. So the actual radius of this function would be natural log of x minus a minus 1. And then we square that. And then we're going to take away the other area, the area of this section right here. And the radius of that would be the y value of sine of x over 2 minus a minus 1 squared dx. And we're going to integrate that monster from the solution of wherever ln of x equals sine of x over 2. Which, let me go ahead and put that into the calculator real quick. Solve ln of x sine of x over 2. And I'm getting a value of 1.008. And then we are going to solve for sine of x over 2 equals 0, and that should be at 360, but we have to put that in radians. That's going to be 2 pi radians, and so hopefully you saw here that that's 6.28. Okay, so you throw that into your integral or into your calculator. Let's go ahead and actually do that. So let's see, 1.008 all the way to 2 pi of pi times the radius. And that radius again is natural log of x plus 1 technically, and you square that monster, minus sine of x plus 1 quantity squared dx. And after you're done integrating that, your calculator should spit out 36.7. If it doesn't, make sure that you are integrating in radians so that all that stuff is resolved correctly. Alrighty, so for number 60, I tried looking at it for a couple minutes and I really couldn't come up with any bit of a solution. And I really hope someone here is quite the clever individual and is able to solve it. But a lot of times when we're dealing with circles touching these lines, one of the things that we want to keep in mind is that at the point of tangency, we can form right triangles. And and that's because any line that is tangent to a circle is going to be perpendicular to the radius. So this right here happens to be r. Now, if we continue building our solution, we're going to go the same distance r over here, then 2r, then r. And so sadly, we don't have an angle and we don't have anything else to build up on, because maybe I was thinking, okay, we have 4 radii, that's 2 diameters here, so 2 circles fit somewhere here, but there's no way that I can connect 2 circles in another dimension here with a number that they give us. They don't give us any other dimensions. Then I was trying to find out, maybe with this angle, we can find out that distance. And if we know that distance, we also know the distance down here. And together, we can go ahead and add that with the 3 radii. And then we can set that all equal to 3.79 and divide it through. But we don't know that angle. And if we knew something about this angle, we could cut it in half and resolve it. For now, in the interest of time, I'll go ahead and getting these videos up. I'll go ahead and submit this, and I'll leave that challenge up to you.